Okay, 3.4 reactant masses. Now, that is the topic for calculation of mole, reactant masses, etc. Actually, in your DSC paper 1A, altogether there are three passes for asking you for calculations. Number one, this part, calculation of mole. Topic 4, accident basis, asking you for calculations of molarity concentrations. And part 3 will be in topic 8, chemical reaction energies, asking you for enthalpy change of reactions. Okay, let's go back to here. Number one, you need to understand what is meaning of Avogadro constant. Now, actually, in this topic, calculations remains the most important part. You understand, and then you are able to calculate, get the answer with the correct unit. That's it. Okay. Not much concept, a definition you need to memorize. Okay, and of course, calculator. Okay, is a must. Okay, go to get back your calculator. Number one, Avogadro constant, which often referred to a symbol, capital letter L. L. Okay, obviously it is discovered by Avogadro's. Now, it states every substance contains uncountable number of particles. Okay? Uncountable number of particles. Okay? The particles can be atoms, ions, or molecules, right? You should be very clear of, right? And it is nonsense to count one by one, piece by piece, right? Because each item, okay, like sodium chloride, it has uncountable number of sodium and chloride ions, right? So, for example, like you go to the supermarket, you seldom buy an egg, one piece of egg, right? You will buy 1,000, okay, 12 eggs, right? Okay, these are practice in supermarket. But in chemistry, our practice is to count the particles by 1 mole. 1 mole is similar to 1,000 concept. 1 mole, okay, is referring to this number, 6.02 times 10 to the power 23. This relationship, okay, you need to aware about it. And this number, you should be able to write down in exam, okay? This number is referring to Avogadro constant, okay? It states 1 mole of any substance contains 6.02 times 10 to the power 23, that particular particles, okay? Now, if 1 mole contains that amount of substance, okay, so we can have this relationship. Now, this relationship is no need for you to memorize. Why? Because if 1 mole, we have 6.02 times 10 to the power 23, right? Then 2 mole, it contains 12.04 times 10 to the power 23. Okay, how about 3 mole? 16.06 times 10 to the power 23. Okay, easy, right? Okay, now this relationship, okay, is common sense, but I forgot to let you know, put a 5-star here, okay, important concept. But quite often in the DSC, okay, they will give you information, okay, further information. You need to rewrite this formula into that. What's the meaning by that? Mole is equal to mass divided by molar mass. Mass, the unit is gram. Molar mass, where you can find it? Oh, you can check this out from the periodic table, okay? Times L, that's it, okay? No panic, okay? We will practice the exercise, okay, soon. Let's take a look on the cast work. How many oxygen particles are there in 1 mole of aluminum oxide? Now, maybe I just read the questions. Now, as far as you learn from the formula, for each aluminum oxide, it should contain 2 aluminum cations, right? And 3 oxygen anions, right? It's very common sense, right? Then, now, if each aluminum oxide contains 3 oxygen particles, then how about 1 mole of aluminum oxide? Oh, it's easy. If each aluminum oxide contains 3 oxygen particles, then how about 1 mole of aluminum oxide? It contains 3 mole of oxygens. Okay? If you don't understand, you go back to this concept. Or 1 mole, that means 6.02 times 10 to the power 23 of aluminum oxide. It contains 18.06 times 10 to the power 23 of oxygen particles. But if every time I say times 10 to the power 23, blah, 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 it's very redundant, right? Okay, so for convenient presentations, we use 1 mole, okay? And then contain 3 mole of oxygen particles, okay? That's it. Okay, I hope you can get it, right? Okay. Next, now how many oxygen atoms? Now please be precise of the burden. How they asking you atoms, okay? Ions, molecules, atoms in 500 grams of water. Water, of course, you very fast. You can say the formula H2O, right? Okay. Because they give the mass, okay, and also there is molar mass here, so you should be able to calculate the mole to put it back into the formula. Then how to calculate the mole? A mole is equal to mass divided by molar mass, right? Mass is here, molar mass you get it by yourself, okay? Number of hydrogen atoms, okay? Mass divided by molar mass times L, right? Okay, and then mass is 500. Molar mass, water, oxygen, 16, hydrogen, 1, right? And what next? Because each water molecule, it contains 2 hydrogen atoms. So you need to times 2, okay, to reflect, okay, this molecule contains 2 hydrogen atoms. Okay? And then times L. Okay? You will got this number. Okay? Okay, next page. Okay, question number 3 out of syllabus. Okay, we better skip it. Next, now for question number 4, this style, okay, you can memorize by some technique how to calculate. I'm not asking you to memorize the number, memorize the technique. Now, there are 2 statements. Okay, number 1 statement. Okay, we can convert it to a formula. Atoms, Y atoms. Okay, number of atoms equal to mass over molar mass. Mass is 1 gram. Molar mass 16 times L, right? If you forget, you refer to the previous page formula. And then we write this formula. Okay? You put L on one side and then flow the rest of the item to another side. L is equal to 16Y. Why we need to do this? Can you take a look on the answer? All of the answers are expressed in terms of Y. Okay? Now, for the green statement, we finish. Then how about the blue statement? 6 grams of C12 equal to what? mass divided by molar mass times L they are asking for. But can you see the L? It is the final answer. We cannot able to find any answer with L, but we all found the answer with Y. So can you able to relate the two statements together? Can you put L into this formula? Oh yes. Okay, after you put L, you will got 1/2 16y and then 8y. So that's the answer. Okay, that's the technique in attempting this kind of questions. Okay, next. Which one contains same number of atoms as 6 grams of water? Now, 6 grams of water, you need to calculate how many atoms, not molecules, atoms inside water molecule. Okay, let's take a look. What formula we need to use? So far we only learned one, right? One formula. Number of atoms refers to equal to mass divided by molar mass times L, right? Mass divided by molar mass times L, right? Oh, why there's a 3 here? Why there's a 3 here? Oh, because every water molecules, there are altogether 3 atoms. H2O, right? So we need times 3. Okay? Then, number of atoms in water is L, single L. Okay? Now, let's go to try by yourself. Okay? Pause your video for 3 minutes. Well, let's get back for the answer. 1.3333 helium. Then mass divided by molar mass times L. Now, no need to calculate because you cannot simplify as one single L, right? Obviously not the right answer. Don't ask me why. So why no need to times 2 times 3? Helium is monoatomic molecule. How come you need to times 2 times 3? Carbon monoxide. 14 divided by is molar mass, right? And times 2. Why? Because you should know carbon monoxide, the formula is CO, right? Okay, so we need times L. Okay, after simplify, you get L. B is the answer. Then how about C and D? C and D, okay, you calculate by yourself. Okay. In which ammonia, the formula is NH3. Carbon dioxide CO2, right? Okay, everyone should know about this. Okay, question number 6. Now you see year by year. Okay, the question is kind of similar to each other, right? 1 gram of carbon monoxide contains same number of atoms in 1 gram of gases. Okay, then you should calculate how many atoms are there in 1 gram of carbon monoxide. Okay, let's check this out. Number of atoms, mass divided by molar mass, times 2 times L, Y times 2. There are 2 atoms in the molecule. Okay, you got this number. Okay, your task is to calculate the rest of them. Which one has the same answer with that? Okay, pause your video for 2 minutes. Okay, let's get back for the answer. Nitrogen. 1/molar mass times 2 times L. Okay, A look like, okay, the right answer, right? 2, ethane. What is the domestic use? Ethane is a components in the natural gas. Okay, C2H4. 1/molar mass times 6. Okay, you can able to see 6 atoms, right? Obviously, that's not the right answer. C, carbon dioxide, okay? Mass over mole mass times 3 equal times L, okay? Obviously not the right answer. So only A is the right choice. Okay, that's it for the Avogadro constant, right? Okay, second term you need to learn about is molar mass. Now, molar mass, you should be able to check this out from the periodic table, but some of you still have no idea about this. In the periodic table, there is a boxes and then there's element symbol inside. On the top left-hand corner, atomic number. Bottom left-hand side corner is referring to the molar mass. Okay? Now, molar mass has its unit, gram per mole. How we can divide the unit? Now, the unit no need to memorize for this. Okay? Now, because you learn about mass divided by mole equal to mass divided by mole mass, right? If we write this formula, mole equal to mass divided by mole mass, then molar mass will be equal to mass over mole. Mass is gram, mole mol. So obviously the unit will be gram per mole. If you familiarized it with the formula, okay, actually no need to memorize the unit. Okay, your memory is limited. Okay, don't waste it. Just take one example. Okay, sodium sulfate. How to get the molar mass? Okay, you add 1 by 1 from the periodic table. Sodium is 23.0, S is 32.1, O is 16.0. So you add up together will be 142.1. Okay, of course I can able to memorize. Okay, you need to refer to the periodic table. It's normal. And okay, next mole. This formula, okay, you have saw this in the previous pages, right? Okay, unit MOL. Okay, let's go ahead. 1 mole of calcium bromide contains what stuff? Okay. Number 1, you should aware the formula CaBr2, but not CaBr, Ca2Br, etc. In 1 mole of calcium bromide is contain 1 mole of calcium cations and 2 mole of bromide anions. It is clear. If you are clear about this, it is easy to figure out which one is wrong. Number 1, A. Now you can pause the video from time to time to check this out. Okay. If you just listen to what I describe, okay, you don't think about it, in the exam, okay, you will encounter the same mistake. 1 mole of molecules? Huh? Molecule? Molecules? It is a molecule? No, they are ionic compound. Ionic compound is different from molecule. Oh, then maybe you ask me, oh sir, why this ionic compound? Excuse me? Presence of metal in the compound must bonded by ionic bond. So it is obviously ionic compound. B. 2 moles of cation. 2 mole? Are there any 2 in front of calcium cation? No. Are there any 2 moles of anions? Yes. Are there any 3 moles of atoms? Some of the candidates are very smart. They think that 2 plus 1 or altogether 3 moles of atom. Sorry, not atoms. Atoms are wrong. Okay, be aware of the terms they are using. Okay, they try to fit you. Okay, in any means. Next. Question 2, we skip it because it is an Asian year past paper, okay, and somehow confusing. Okay, question number 3. Wait. The molecular formula of a gaseous element X is S2. That means it will form. It exists as a room conditions. Room temperature and pressure as S2. If the relative atom mass of S is 19, what is the number of molecule? Are they asking for molecule in 114 gram of the gas? How to make it? Now, when they're asking for number of molecules, that means they are asking for particle, right? Particle. Because particle include atoms and molecule, right? Okay. So we will using this formula, okay, as usual. Mass over molar mass times L, right? What's the mass? 114. What's the molar mass? Okay, check this out here. 19 is just 19. Of course not. Diatomic molecule. Okay, 38. Okay. Oh, some of the candidates will write down times 2. Maybe you may ask, well, sir, why previous page you times 2, but now no need to times 2? Because they are asking for molecule, the whole molecule. If they're asking for atoms, you need times 2. But now they are asking for molecules. So please be aware of the burden they are asking for. Okay? There is no any method for you to memorize. Okay, you need to be aware of how the question is going to ask. And okay, simple calculation, 3L. Okay, 3L. Okay, C. Okay, next. Question number 4. 4 grams of morphine. Now you should be aware some formula of common hydrocarbons like morphine, ethane. Okay. Now maybe I didn't clarify. ANE only single bond present between the CC atom. Of course, how about ENE? ENE, there is double bond in between the CC atom. Okay, you will learn this in topic 6. Topic 5, fossil fuel and carbon compound. Okay, don't worry. 4 grams of morphine contain S molecules. How many molecules? Molecules again. Molecules. Okay, they are not asking for atoms. Are there in 8 grams of oxygen? So number 1, we calculate the number of molecules in 4 grams of morphine first. Okay, mass divided molar mass times L, right? Okay, we are calculating the number of molecules. Okay, you get 1 over 4L. 1 over 4L. And because you can able to see the answer is expressed in terms of S. Okay, so you need to convert, okay, the first statement, the formula, to 4L equal to 4S, and then substitute this formula to the second statement. The second statement is 8 gram mass divided by molar mass, okay, times L, 1 over 4L. Okay. Now, until this point, if you forgot to try the conversion, then you cannot figure out the answer, right? You will try the conversion and then put it back. Okay, equal to S. Okay, simple calculations. Okay, next. Another style. Cause out the burden of mole. What is the number of sodium cations in 75 grams of sodium carbonate? Number 1, how many sodium cations in 1 mole of sodium carbonate? How many number of moles of sodium cations in 1 mole of sodium carbonate? Obviously 2 mole, right? Okay, so we need to times 2. Okay, they are asking for 2 they are asking for ions okay, so mass over molar mass times L, you got the answer. Okay, please use your calculator to manipulate your answer once. I'm sure some of you cannot able to get the same answer. Okay, because your mass is quite weak, you should know about this. Next, okay, percentage by mass of an element in a compound. Now this part usually asked in MC question or some structural question, maybe part D, part E. Okay, only 1 mark. Okay, only 1 mark or maximum 2 mark, but usually 1 mark. Yeah. If 2 mark, 1 mark for the formula, 1 mark for the answer. This formula, no need. You know how to write down the formula is already okay. Okay. Now, number 1. If still you cannot able to write down the formula of potassium dichromate or sodium chromate or potassium permanganate, okay, please go back to topic 2 to memorize the name of the ions and the formula of the ions. Okay, you already learned in kindergarten level already. Okay. Percentage by mass of chromium, you can write percentage chromium. Okay, and then fractions times 100%. What we need to put on the fraction? Now on the bottom, okay, we will put the molar mass of the whole compound. Already provided here, okay, add up 1 by 1, okay, no any difficulties. If not provided in the question, go back to the last page of your question booklet. It will be provided in the periodic table. And on the top, we put the molar mass of chromium, okay, 52, right? 52, right? But quite a number of candidates, if they are asking for chromium percentage by mass, they missing the 2. They missing the 2, which is completely wrong. You will pick up the wrong answer exactly. You will pick up 70.7, okay? So please be aware, please be notice, okay, highlight this, okay. And once again, dichromate is very common to be asked in DSC, yeah, because they want to check whether the candidates are aware there's 2 chromium, okay. And then answer of obviously the unit, okay, is percentage, okay. Next. Another style, now this one is the most easiest style, okay. How about alternative style? For example, H2S contains 15.8% of H by mass, right? What's the relative molecular mass of atomic mass of H? That means they're asking for molar mass of H. Okay, we construct formula because you can able to construct formula because you already provided with the percentage by mass of H, right? So that means you need to have a fraction times 100% u to 15.8%, right? Like this. H is unknown. H also unknown. But you know the bottom, we put the molar mass of the whole compound, right? H plus 2 times 32.1 on the top H, okay? In this formula, how many unknown? Obviously 1. Can you be able to calculate this? Of course, yes. Okay, try by yourself. Okay, don't rely on the answer I provided here. Okay, I am sure quite a number of you cannot able to solve the S here. Okay, let's pause the video for a while, okay, to get it well done. Okay, number 3, hydrated, okay, salt. The hydrated salt can be hydrated, maybe magnesium sulfate, maybe hydrated calcium carbonate. The number of waters, we can say this is the water of crystallization. Do you remember? The ions are existed in the ionolactons. In the ionolactons, there are still some empty space for the water to get inside. But the total compound is existing as a solid. Okay? The number of water of crystallization is different from salt to salt. For example, magnesium sulfate, the S is 7. copper sulfate is 5H2O. Of course, you will not know the number. Okay, you need to calculate for this. Okay, they say it contains 20.9% of water crystallization by mass. Okay, how to get it? Okay, same as question number 2. But fractions. What we need to put on the fractions? They say 20.9% is the water of crystallization, right? Okay, so here 18H, right? Bottom, you add up the whole hydrated salt. Okay, the molar mass, add up them. And then times 100%, you will equal to 20.9. Obviously, only one unknown. Can you able to get it? Should be yes. Okay, try by yourself. Okay, and this is a kind of reminder. What is meant by water of crystallization? It refers to water molecule it existed in the iron lactans. Okay, but still it is solid. Quite a number of candidates, they think that if they saw this formula, it is AQ, wrong. Okay, totally wrong. Okay, hydrated salt must be solid. Okay, next. For the coming 3 questions, maybe I left for you EYT. Okay, the marking you may refer to the demonstration notes I uploaded to the Google Classroom soon. Okay, don't worry. And next, empirical formula. Wait for a while. Okay, empirical formula. Formula like H2O, CO2, HCl, H2SO4, like C2, H4, etc. They are all referring to molecular formula. Okay, it shows us the actual number of atoms in the molecule. In the compound. But how about the empirical formula? Empirical formula, we often refer to the simplest whole number ratio. Okay? For example, due to the coronavirus outbreak, quite a number of you, even me, may search for sanitizer, sterilizer, disinfectant, okay? But which ingredients is effective for curing virus? Okay? Coronavirus, okay? Hydrogen peroxide is one of the effective ingredients in the disinfectant, okay? Except hydrogen peroxide, okay, maybe ethanol, 酒精, maybe what else? Maybe this one you may not heard about this. Benzalkonium chloride. Yep. Okay. I don't go too far. Now maybe hydrogen peroxide. This is the molecular formula, right? Then what is empirical formula? Okay. Light mass 2. It can simplify. It's 1. So the empirical formula for H2O2 is HO. How about butane? Now, if 1 carbon, we will begin with methane, METH. How about 2? Ethane, ETHANE. How about 3 carbon? Propane, PROPANE. How about 4 carbon? Butane. Okay, butane is one of the important ingredients in the portable gases fuel. Okay, for hot pot in winter. Okay, you know hot pot, right? Okay, you need to have the fuel, right? The portable gases, okay, to add the activity, the ingredients, okay, inside. Okay. Oh, simplify. CH2 is the empirical formula for C4H8. Okay. Then how about this one? Okay, simplify. Okay, you got it. Okay. And then okay. Now, not usually, it is a must. How to get the empirical formula from experiment? Empirical formula must be obtained by an experimental method. Okay, like this. Perhaps you may ask me before, why magnesium oxide? The formula must be MgO, but not MgO2, but not Mg2O, but not Mg2O2, etc. We can determine its molecular formula, okay, by this method. Number one, we will have a crucible, we will have the lead, we put the magnesium ribbon inside, strong heating in this setup. After strong heating, magnesium should react with oxygen to form magnesium oxide, right? Right? And then we will measure the mass of magnesium oxide obtained. Okay? And the mass of oxygen reacted. Or on the comment pages, you will know about this. Okay? Before we manipulated the data table, we take a look on the procedure first. Number one, crucible and the lead are weighted and record. Okay, are weighted and record. So that okay. Maybe you refer to the next page table from time to time. Okay, crucible and the lead. Okay, we record the mass, and after we add the magnesium, we will got the mass a little bit bigger than that. So how heavy is the magnesium added? Okay, it's just subtraction. Okay, now this is the method of a subtraction method. Okay, we usually if you are asked to put maybe a certain mass of magnesium into the crucible, okay, we will add by this subtraction method. Okay, and then you get the known mass. During strong heating, the lead is half, okay, open. Why? To provide enough oxygen for the oxide formation. If you cover it, then how come oxygen can get inside? Maybe not enough oxygen to get inside. Then the oxide formed, okay, will be unusual. Okay. 10 minutes later, okay, after sufficient cooling, you can define the empirical form by experimental data. Okay. Steps are not important. Important is how to manipulate the data. Okay. Now, your notes is empty, right? Okay, try to calculate by yourself. Pause yourself for maybe 1 minute. Okay, let's check this out. Just subtraction, you will get 0.92. Wait, how to get the mass of magnesium oxide? Oh, this number, deduct this number, you will get 1.53, right? Then how is the mass of oxygen? Okay, reacted. These two numbers, okay, subtract each other. You will get the mass of oxygen reacted in the reaction. Then you need to able to draft the following table. However, in the exam, the foreign space is empty. Okay, so number one, you need to memorize the 4 columns here. Number one, mass, mole ratio, simplest mole ratio is a must to memorize. Okay, now sometimes if the information given is percentage like this, okay, you may assume the mass of the unknown is 100 grams. Then the column here will be relative mass. Okay, but minor mistake if you even write down mass here, okay? Important is the data you drop here is correct and get the right answer, okay? And if there are more than 2 elements in the compound, okay, write down one more row here, okay? 0.92, 0.61, okay, now step by step, okay, just copy, okay, no panic. And mole, mass divided by molar mass, mass divided by molar mass, okay, it's still easy, right? Take more decimal place is okay because this number, this figure, you will use that in further step. Mole ratio. Now mole ratio, this step you need to pay attention. Quite a number of you did not understand. Okay, do not understand no matter how many times I tell you. Which number is smaller? Obviously this one. If this number is smaller, then divided by itself, 1. Bigger number also divided by the smaller number, you will get 1.0070. Okay? And then simple small ratio, close to 1. Okay? So based on this calculation, we can conclude that the 1 mole, actually in the reaction, 1 mole of magnesium react with 1 mole of oxygen to get 1 mole of magnesium oxide. So obviously the formula will be MgO, but this formula is empirical formula only. Okay? So we do not have MgO2, Mg2O2, etc. Okay? Okay. Okay. Now let's try the classwork. Okay, pause for maybe 5 minutes. Okay, now let's check the answer. Now, for what? Now, sometimes the question may give you the percentage by mass. Okay, HOC, right? Okay, and it has a relative molecular mass of 18 to 100. 80 to 100. Okay, details that means you need to show step. Of course, you need to write down a table. But before you write down the table, please, okay, assume, okay, make an assumption. Now, because unlike the previous question, they only give you percentage. They didn't give you the mass, exact mass. You can assume the mass of S to be 100 gram. Okay, if 100 gram, then it got 9.2 mass gram of hydrogen, 36.4 gram of oxygen, 54.4 gram of carbon, right? Okay, like this. Okay, now, but because we assume here, so it is relative mass. Relative mass, they don't have units, so just write down like this. Okay. For the previous table, you can write down gram. Okay, this one has unit, but that one did not have unit. Relative. Next, mole. Still easy, right? Divided by molar mass, C molar mass, divided by 12, divided by 1, divided by 16. Okay, you got this number. Oh, how to get the mole ratio? Oh, this is a critical step. Okay, quite a number of you, okay? No idea, okay? You will use your own method. No. Which one is the smallest? 2.275, right? All of the 3 numbers divided by 2.275, and you will got 1.9925, 4.041, and 1. Okay, so the simplest mole ratio will be 241. Okay, so another mistake. Some candidates will write down molecular formula equal to C2H4O. Oh, sorry, wrong. You didn't make use of the second information. Molar molecular mass is ranging from 80 to 100. So, how to relate the answer empirical formula to 80 to 100? Now, from the table, what you have got is C2H4O. Now, but you should know molecular formula is equal to empirical formula with a bracket N, right? N must be whole digit, right? Do you remember the concept at the beginning of the lesson of this topic. N must be 1, 2, 3, 4, 5. Cannot be 1.5, 2.5, 2.4. And how to get the value n? 80, I get it here. 100, I get it here. Divided by the molar mass of empirical formula, okay? C times 12 plus 4 plus 16, okay? You will get the n will be 1.8181 to 2.2727, okay? But I say n must be whole digit number. N must be equal to 2. 2 is within this range and whole digit, right? So the molecular formula, you put back to this formula, you will got C4H8O2, okay? And in Form 5, you will learn the topic 5 fossil fuel and carbon compound, okay? They will ask you, okay, how to draw the molecular formula, okay? But now you know the molecular formula is very okay. Part C, part B, part D. Part B, part C. No need, because you may learn it in topic 5 fossil fuel and carbon compounds, okay? And now pause another 1 minute, 1 minute, because MC you can only use 1 minute to try the question number 2, okay? Answer provided here, okay? But you need to draw a table, okay, to accomplish your answer, okay? Perhaps that's it for today's lesson, okay? Please stay tuned to the video I uploaded in the YouTube and Google Classroom, okay? Work hard, don't give up, practice, perfect practice, okay? Match perfect. See you.